Thanks for having me. Really appreciate it. Yeah, even in the last couple of minutes, and actually when I first joined, this whole experience so far has made me realize I've been coming into this with a very specific idea in mind of what sensory augmentation means to me, and I think it's a lot more. It's not as clearly defined as I actually thought it was. So I'll just while Mariana was talking, I actually let's see. There we go. While Mariana was talking, I actually made a quick slide on my definition of sensory augmentation. Not the prettiest slide, but how I've been envisioning sensory augmentation as a field has been this idea more from an electrical engineering perspective of how do we create new senses and what's a framework for modeling that. So for me, and this came out of my PhD work, which led into sensory, is the idea to me of taking new senses is you have some input information stream that you care about. It's a signal, whether it's stock market data, weather data, a sensor network, whatever you can think of. And the idea is, and the goal is to find an appropriate mathematical representation of that signal such that you're trying to guarantee that as much of that information is being coded to a set of target sensory receptors on your body, and trying to guarantee that as much of that information as possible makes it to the brain, with the assumption that if the brain can receive this information, we know the peripheral nervous system is picking it up, that's sufficient for the brain to train up on new senses. But maybe that's a different definition semantically than like this broader notion of what we call sensory augmentation. So with that being said, I think it's in a weird place. Neosensory, quick bit of background. This is a bit of a mouthful, but we develop wearable, non-invasive sensory augmentation platforms for creating what I call new high throughput senses. And by high throughput, I mean providing information that's not like a simple notification, but information that has densities, ideally densities on the order of like what you'd expect for vision or audition. We're not quite there yet in the technology that can support this, which I'll get into in a second. More specifically, this wristband out of the box, we do have an algorithm that runs a sound to touch application. So in real time, it's taking sound from the environment. There's a microphone on board this wristband. Yeah, I completely just glossed over. Our product that we sell is called Buzz. It's a wristband. It has 4 vibrational actuators in it. And it's a platform for performing this sort of work. And out of the box, it has a sound to touch algorithm where it's taking sound from the environment and mapping it to an equivalent vibrotactile representation, a compressed vibrotactile representation around the wrist. The most obvious use case for this is probably for people who have profound or severe hearing loss, but there's a number of other cool use cases for it as well. But more importantly, we have a developer API and we let developers plug in whatever data streams they want into this hardware over a Bluetooth Low Energy interface. And we've been running hackathon contests for about a year now or so, and tons of great applications have come out of this. Highlighting just a few here. So people have done stuff like providing sensory feedback for prosthetics, providing a sense of electric current, echolocation, and our hope is that developers will commercialize their own applications on top of this platform. And we've started to see this. One of my favorite projects is with this group now, startup company called Valence, and they are performing a real-time speech sentiment / emotion recognizer on speech audio and encoding that to the wrist to help people who are neurodiverse, who have a difficult time navigating conversations and getting these types of social cues, and providing this as kind of an aid in that regard, which is super, super cool stuff. So definitely check out Valence if you can. So just to take a step back, we've come a long, long way together. Props to anyone who gets that reference. It's been close to 100 years now since what I consider to be kind of the first paper kind of on the subject of sensory augmentation came out from Galt in 1923. Highly recommend checking this paper out. But since then, obviously there have been some major advancements, but it's been a long time and it's been slow going. So, in 1969, we had Baki Rita kind of more formally establish this field and call it sensory substitution with his famous study on vision to touch, vision to touch sensory substitution. And then kind of through the 80s through 2000s, we had this advent of tactile hearing aids, which was really cool. And then they kind of disappeared out of nowhere in the early 2000s. And then we had the advent of the tongue display unit, TDU. But from 2005 onwards, I would have expected to see a much more rapid advancement in sensory augmentation than what we have seen. And to be fair, there has been a lot more going on. But since 2005, not to keep saying the word advent, we've had the advent of portable, cheap, dense energy storage come about. We've had more user-friendly electrical engineering thanks to the maker movement and projects like Arduino come about. We've also had mass adoption of powerful, cheap, real-time embedded processing, which is now in all of our pockets. And fast forward to 2021, this is not an exhaustive list, but there are barely any companies. There's maybe a handful of companies, certainly a lot more academics out there, but a handful of companies that have successfully, or to be determined in terms of success, ourselves included, with commercializing sensory augmentation technology, which is kind of a curious thing. I mean, so I'll just give a few shout outs. I mean, the ones that I know of, and I'm sure I'm missing like just a couple of others, you know, Brainport from YCAB out of Baki Rita's group. There's The Voice. There's Liviu's company, Cyborg Nest here with their Sentero platform, and there's Neosensory Buzz. And as far as I know, Sentero and Buzz are the only two products right now acting as kind of more general purpose sensory augmentation platforms. So it's a very curious thing that's been almost 100 years, and yet this is how far we've come. And I'm personally mildly disappointed by where we are now. I wasn't promised, but you know, in 1999, I was hoping for the Matrix, and I was hoping that would come a lot more quickly, and that hasn't been realized yet. So why is that? And I think a lot of it comes down to user experience. And I think the technology needed to enable like mass adoption of sensory augmentation technology, the user experience the technology isn't there to support that needed user experience. And by user experience, I mean not just the product design and how people interact with the product, but also the neuroscience of this. So most of us, I'm sure all of us know on this call, that training senses takes time. Large-scale cortical reorganization occurs on the order of several weeks, if not months or years. And so using sensory augmentation building sensory augmentation technology means that people need to be willing to wear this technology persistently all day, every day, from like when they wake up to when they go to bed, if you want to successfully entrain new senses. And so because of that, I think haptics, and I have strong opinions that haptics are the solution to this for large scale mass adoption. I think there's other more niche situations where haptics, you don't need to use haptics, like in the case of what Brainport's doing or in the case of what The Voice is doing. But if you want large scale mass adoption of sensory augmentation devices, you know, obviously I'm a bit biased with what we're doing at Neosensory, but I do think haptics is where it is. It's the only sensory modality that is capable of supporting high information data rates where it's not persistently being used for other activities throughout our daily lives, like vision and touch. And so haptic technology just has not caught up with other sensory, with the technology for stimulating other sensory modalities, especially for parallel information transfer. So just as a little quick example, right? You can get a 128 by 32 OLED display for around $6 and it draws 50 milliwatts of power. The cost per like kind of, let's call it a pixel or sensory stimulating point is less than a cent, and it's less than 1/10 of a milliwatt for that. And I'm leaving weight out of this too. Contrast that with in haptics, you know, you have LRAs, and that's, yeah, this could get down like into a rabbit hole with people who specialize in haptics, and we can save that for later. But just take a tiny LRA, a little vibrational actuator, that's $2 and 30 milliwatts for a single point of stimulation. So we're talking about a cost in terms of weight, energy consumption, money, and information it's 1,000 times, several thousand times more expensive than what these other modalities can achieve. So my call to action is we need sensory stimulation devices designed for augmentation. I think a lot of what's being used right now is being pulled off the shelf. And again, this is in the context of mass market adoption. But a lot of what we're using right now are stimulating devices that were not originally or initially designed for sensory augmentation. They're designed for other applications that we've been taking off the shelf and working with. Like, for example, the LRAs in our Buzz wristband. And then second, I think we need tighter mindshare across industry and academia in this space. And to that end, I need to give a lot of props to the Making Sense crew for getting this stuff going. I know there's some academic meetups and things happening around here, but in my 10 years of being in this field, I'm actually a little bit surprised at the lack of integration across industry and academia that's been going on. And a lot of the research that I see happening in the space tends to piggyback within other fields. So for example, you'll see sensory augmentation, I think of as more of a niche within, for example, neuroscience, or you'll see some papers or presentations over at Society for Neuroscience, or some niche, a niche area within like IEEE haptics, stuff like that. So props to the Making Sense crew, good stuff getting this going. And so that's my second call to action. And that's it. So thank you, and looking forward to a stimulating discussion.